For disk layouts with one or more file systems, we will look at two boot and partitioning layouts: the master boot record, MBR, an old legacy layout not much used today, and UEFI together with GPT, the GUID partition table, where GUID stands for Globally Unique Identifier. With the master boot record layout, a disk can have different partitions, each containing an independent file system. Each partition begins with a boot block, which contains executable code that, once loaded into memory, can start the operating system associated with that partition, if the partition contains one operating system. The blocks after the boot block depend on the specific file system in that partition. At the beginning of the disk, we have the master boot record. The MBR is the first sector and contains both boot code and the partition table. When the machine starts, it loads the executable in the MBR, which reads the partition table and chooses which partition to use to load the operating system, possibly asking the user. The partition table contains the addresses of the partitions. If one partition is marked as active, it is selected to load the operating system by reading the partition's boot block. The MBR layout has been used for decades, especially when rotating disks were common in computers and laptops. It has several limitations. The MBR is limited to 512 bytes, including the partition table, so it often cannot contain all the code needed to boot and must load more code from another disk section. It also supports only up to 4 primary partitions. With legacy BIOS booting, execution starts in 16-bit real mode, using 16-bit registers and instructions without paging, which is no longer how modern hardware normally works. Finally, given the bits used for the partition start address and size, and the assumed sector size, MBR can only handle partitions up to about 2 terabytes. Let's move now to the Unified Extensible Firmware Interface, UEFI, which is the common layout today and which is more complex but offers richer features. The first block is still reserved for an MBR in case legacy tools expected. This is called the protective MBR. It tells legacy MBR tools that the disk is occupied, so they do not treat the GPT disk as empty. After that, block 1 contains the GPT header, followed by the GPT partition entry array. The actual partitions follow after that. At the end of the disk, there is a backup copy of the GPT. This backup contains a backup header and partition entries, so the partition table can be recovered if the primary GPT is damaged. One difference with MBR is that we are not only loading a small program that decides which operating system to load. Instead, there is a specific partition called the EFI system partition, which contains a proper file system and executables. More concretely, UEFI loads .EFI boot programs from the EFI system partition.